Okay. So in this diagram, we have two shapes. We have two triangles, PQR. And then we have another triangle, LMN. So we did a few things to one shape to get to the other. What do you first notice about its size? Yeah, the size has changed. If the size changed, what transformation do you know we did? Yeah, we would have had to have dilated. Okay. So not only did it get larger, but then what happened? It spun in some way. All right, so maybe a rotation, depending on the positioning. There's a couple other transformations. Did it translate?
Yes.
Is it only a dilation and a translation? Like, did I just make it bigger and then slide it? No, I did something to actually, like, turn it additionally. So PQR, this shape here, was flipped. What do we call a flip? It was reflected. Where, if I reflected this image, what was my axis of, my line of reflection? The y-axis, yeah. Imagine here if I took this image and flipped it right over, it would look something like this. Right, if I just reflected it. So I reflected over the y-axis. But then, after I reflected to this new black triangle that I've drawn, what did I do? So then I notice now, it's in the exact same position, but I dilated it. How much did I dilate? How can I figure out what the dilation was, like what the actual scale factor was? What did I multiply by to actually make it bigger? What do you think I can compare? Think back, I know it was a while ago because we had 2 snow days, but on Tuesday when we dilated, what did we do to actually make the image get bigger? What did we multiply? Well, we multiplied by 2 in that example because the scale factor was a 2. What were we multiplying though?
The scale.
So we multiplied our scale factor by the coordinates. So if I know the coordinates of the original and the new, do you think I can figure out what I multiply by?
Yeah.
All right, so on this original image, what's that coordinate right here? X is 0, y is 2. Okay. How about this one? X is 2, y is 0. And how about this one? X is 4. Yep.
And go up 1, 2, 3, 5.
4. All right, how about the new figure? What's that coordinate? 6, 6. So I went from 4, 4 to 6, 6. I went from 2, 0 to what?
2.
So 3, 0. And then I went from 0, 2 to 0, 3. To 0, 3. What do you think I multiplied by? Think about going from 4 to 6. Did I multiply by 2? No. Did I multiply by 1? No. Because it would have stayed the same.
1.5.
I multiplied by 1.5. Or 1.5. Okay. And we were able to figure it out because we had our original figure and our new figure. We could actually compare the movement. Okay, so we can describe the change in the coordinates here because the way we moved it, we transformed our figure in 2 ways. Okay, so, what? Yeah, you can. This is just an example of 2 transformations. So we transformed the coordinate P. That became L. So it went from 3, 0 to, it went from -2, 0 to 3, 0. Point R transforms to point N. and point Q transformed to point M. So we did two things. We reflected it first to get it to that same position, and then we dilated. So while this was the result of two transformations, we can notice a relationship between the coordinates. To go from -2 to a 3, to go from 0 to 0, -4 to 0, 4 to 2. Each x coordinate has an opposite sign and was multiplied by 1.5. The 1.5 represents the dilation. What does the opposite sign represent? What transformation would the opposite sign represent? Like instead of a -2, it became a +2. Instead of a -4, it became a +4. What transformation would actually move it from one side to the other? The reflection. So if you think about what happened here to the coordinates, the opposite sign, that represents the reflection over the y-axis, which we already identified we did. And then the second thing was multiplying by 1.5, and that was the dilation. Now our y values didn't change because from when I reflected, those y coordinates stayed the same.
When you flipped it, it was from the other point. How did the other move up?
The r coordinate is 0, 2, and then I multiplied the 0 and the 2 by 3/2, which is 1.5, so 2 went to 3. So this went from 0, 2 to 0, 3. Because 2 times 1.5 is 3. So that's the dilation. Like it looks like, it almost looks like a translation. Like you slid it up. The difference is if you compare the sizes of the triangles, the translation doesn't really make sense there because the actual size changed. So for this to move up, that was actually the dilation. Because once you flipped this figure over, it expanded. And all of the points were multiplied by 1.5. So we already talked about the two transformations. Does it matter if we reflected first and then dilated, or would we have gotten the same result if we dilated first and then reflected? Think about what would have happened if we dilated first. PQR, where would the coordinates have gone? If I made this bigger by 1.5 first and actually like blew it up before I reflected it. So this coordinate at -2, 0 would have become what? -3, 0. Good. -4, 4 would have become what? -6, 6, somewhere over there. And then 0, 2 would have become what? 0, 3. Could I have done that? Could I have dilated it first and then flipped it? Yeah. The same thing would have happened. It doesn't really matter the order. As long as you're doing the same transformations originally that we did, you'd get the same thing. Oh, let me go back. If I wanted to change the dilation, what would the coordinates of L be? If I had 3, 0, and I wanted to scale factor of 4, what would that coordinate become? What does it mean to have a scale factor of 4? What would I do to that coordinate? I would multiply both by 4, and what would it become? 12, 0. Yeah, it would have been like way out here, but still on the x-axis. So how would you explain, if you had to explain this flip-flop of the x-coordinate going from a -4 to a +6, a -2 to a +3, why are they changing signs? What is the key there with the change of the sign for the x-coordinate? What made that x-coordinate change? Why did the x-coordinate change from a negative to a positive? Because it reflected. Be more specific there. Is it, no matter what reflection I do, will it always go from a -x to a +x?
No.
No, what is it about this reflection that made it a -x to a +x? That it flipped over the y. Good. What would have happened if I flipped it over the x-axis?
The y would have been negative.
Yeah, the y values would have gone from a positive to a negative. Good. Let's say this was our first figure. We started here, and then we made it smaller and did this. Would I still have reflected? Yes. Okay, so I still reflect. What would my scale factor have been?
-4. No.
So instead of multiplying by 3/2 to make it bigger, what would I have done?
Divide by 3.
And what's dividing by 3/2? The same as
Multiply by 2/3.
multiplying by 2/3. And that would have made it smaller. Multiplying by a fraction smaller than 1 would have made it smaller. Absolutely. Okay. We're going to skip over that one. Okay, so we're going to try this one. So here are the two figures we have. You're just going to try this in your notebook. We're going to talk about it, and then we're going to break off and do a couple little activities. Here we have two figures. We have U, V, W, O here. And then we have D, E, F, O. So we did something. We went from this U, V, W, we went from the red figure to the black figure. I want you to identify what transformations you could have done to go from the red figure to the black figure. My first question before you start to figure this out, is there only one transformation you could have done to go from the red to the black? Why no?
Because the size and location change.
So there's a few things going on here. How do you know that you couldn't just dilate?
Because the location changed.
What do you mean?
Like, it flipped over the y-axis.
How do you know?
It's like,
Talk about the shape of the rectangle. Is it possible that I just shrunk down the red rectangle to be the black one?
No.
well, it would become the black one, but just not the replication.
Right, the location did change. Notice that like this red rectangle is like on its side, like long ways, but the black one's like standing up. Okay, so we know it has to be more than one. Now you might come up with different transformations than the person next to you because there could be a couple of things you could have done to go from one to the other. But I want you to try and come up with some transformations. A sequence of transformations that went from UV, WO, the red, to the black. I'm going to put up 5 minutes and see what we can come up with.